Question number 2, chapter kinematics, subsection challenge your understanding, book Pathfinder. One end of a light inextensible thread of length L is held stationary over a frictionless horizontal floor, while a small bead tied at the other end of the thread is describing a circular path with a uniform speed v0 on the floor as shown in the figure. The upper end of the thread is suddenly pulled vertically upwards with a constant acceleration a0. The bead does not leave the floor. Find the magnitude of its acceleration immediately after the upper end of the thread is pulled. Okay, so this is a question. Let's see how to solve it. So from the circular motion, we know if a particle moves with a speed v, and suppose the speed is constant, then we have acceleration towards the center, and its value is v into omega. Omega can be written as v by r, and it becomes v square by r. So it's a well-known formula you all know. And the acceleration is towards 1, that is towards center. There are two directions. Whenever magnitude of a vector remains constant, only its direction changes. The direction of its rate of change happens to be perpendicular to the vector, and there are two directions here perpendicular to the vector v, 1 and 2, and which of these two directions will have dv by dt in. For that, just see the velocity vector after some time, after a small time. So this is the velocity after a small time. So initial velocity, this is velocity after some time, then this is change in velocity. Initial velocity plus change gives the final velocity. So in a time dt, this is initial velocity, this is change in velocity during that time, and these two add to give the final velocity. So since velocity vector, its tip is moving inward, so the rate of change of velocity is in inward direction, that is in the direction 1. So that is towards center. Okay, now again, suppose we have a circle and this is radial direction. Assume a unit vector along this radial direction as r cap, and this is a unit vector in tangential direction, which is denoted as t cap. After some time, these two vectors will have their directions turned like this, and if you write the derivative of r vector, r cap, so since its magnitude remains constant, only its direction is changing. So therefore, how to write d by dt of r cap? Its value is 1, as we have here value v. Then we write omega, so omega, and then we have to multiply the unit vector in the direction of dr by dt. So let's see how this direction of dr by dt is to be determined. It will be perpendicular to r, either in this direction or in opposite direction. Let's see which direction it comes out. So this is the direction of r vector initially, r cap. This is the direction of r cap after some time. So initial vector, this is after some time, initial vector plus change in vector will give final vector. So this is the direction in which vector is changing, and this vector is in the direction of t cap. So therefore, t cap is the direction of dr by dt. Similarly, if you differentiate the t cap vector with time, its value is 1 into omega again, and now see in which direction this t cap is turning, and for that, this is initial direction of t cap, this is final direction of t cap. So initial direction plus change gives final. So this vector is a direction in which t cap is changing, and this vector is in fact opposite to r cap, that is towards center. Therefore, I have written minus r cap. Okay, so this will be using in this question. Now here in this question, this is a top view. So a particle is moving along a circle. This is a top view, and this is side view. From seen from side, the bead is here. It is moving along a circle like this, and this is a string, and this is its upper end, and it's given that upper end is moved upward. Suppose at some instant the velocity of upper end is u. At that time, the velocity of this bead is suppose v, and since this length is constant, the component of u along this length is u cos theta, while the component of v along the length is v sin theta. And since the length of this string is constant, it must be equal, so that the separation between them remains constant. And from here we get v equal to u cot theta. So as this particle is moved upward with velocity u, this bead will move inward towards the center with a velocity u cot theta. If seen from above, this velocity v can be seen towards center. So the writing total velocity of this bead velocity vector, so it has two components. it is v0 in tangential direction, v0 t cap, while v in towards center. So the value of v is u cot theta. So it is towards center, therefore minus r. Differentiate this velocity expression. What I've done, I've written cot theta minus u cot theta first, and the remaining two terms, u and r cap, they are differentiated using product rule. So u dr by dt plus r du by dt. Then I have written u and r cap as constant, and then cot theta is differentiation as minus cosec square theta, and there is one more minus, so that becomes plus, and the last term is differentiated as d by dt of t cap. Okay, so this is the expression we have got. U is 0 because it is the initial velocity of upper end, and since it has just started, so therefore u is 0. So u terms are 0. This is u term, that is 0. This is u term, which is 0. Okay, du by dt. Du by dt is the acceleration of upper end, which is given in the question as a0. And d by dt of t cap we know is omega into minus r cap. And put the value of omega. Omega is v naught upon radius. Radius is L sine theta. So we have this much of total acceleration, and this whole acceleration is towards center. Minus r cap means towards center. Okay, so this is the result obtained. Okay, thank you.